Okay, we are going to look at an ILM question. And so this is out of ILM 030304B, Protection and Control, and this is Objective 5, question number 8. So I get asked a lot of questions regarding this one. So I'm going to take the time here and go through it. Now, there is 9 questions within question 8. And so if you feel that you've got a grasp on them, you can always fast forward it to the one that you are having difficulties with. Okay, so here's the entire question. And what we see here is two different conductors that are terminated together. And we've got to put an overcurrent on this. So it is determining the maximum size overcurrent we can put on it. And what we're really doing with this is we have to figure out the ampacity of each one of these wires and then apply 14104 and put the correct overcurrent on it. Now, this is a great review of temperature terminations because all of these are 75-degree terminations, and all of these wires that they are listed are all current carrying conductors. So you don't have to take one out for the neutral if you have a true neutral. And we do use a variety of insulation temperatures too. So insulation temperature is another way that may knock down the ampacity of your conductor. We use both copper and aluminum. So let's begin. I'm going to look at question number 1 here. And here's the answer. It's 15 amp overcurrent here, but let's have a look at why. So I'm going to go through all 9 of these. Okay, so in question 1 here, we've got 3 14 gauge RW90 wires in a conduit. They're all current carrying, and they are connected to 3 number 14 TW. Okay, so if it doesn't say aluminum, then it's copper. So it has to say aluminum in the module. Otherwise, you assume it's copper. All right. So if you want to look for what we're going to look at here first to distinguish between the two is we need to know, well, we already know it's a 75-degree termination temperature. This conductor is RW90. It has a temperature rating for its insulation, but this one does not. So if you go to table 19, you can look up TW in table 19, and it'll tell you that the insulation for TW is 60 degrees Celsius. So the next step is looking at the ampacity. Because these are copper, we go to table 2. We look up number 14s. They're good to 20 amps. And then over on the second conductor, it is number 14s with a 60 degree. So we have to go to column, the first column there, the 60 degree column. That tells us only good to 15 amps. Now this is a little bit deceiving. So if this was for a known connected load, a special load like a motor or something, we would go off these numbers to size that overcurrent or some sort of a, if it's mentioned in anything other than this is a general section, so this is a general branch circuit. And in this case, we have to pay attention to the rules in 14-104 subrule 2. And it says in that rule that the maximum overcurrent we can put on a 14 gauge wire is 15 amps. So we would have to go with a 15 amp regardless. If it was both over 20 amp wires, because it's 14 gauge and it's a general branch circuit, we'd have to go with a 15 amp overcurrent. So make sure you read through 14-104 subrule 2, or actually read through the whole thing. It's very important. Okay, question 2 here. So we've got 3 number 2 RW75s, which is fine. So we're going to use column 2 because we have a 75-degree termination and 75-degree wire or better. And then we have 3 number 1s, and they're RW90. So they're fine, but they're still terminating with 75 degrees Celsius. So we have to go down to the 75-degree column with that. So going here, remember table 2 is for 3 current carrying conductors, so we're still good at 3. So we go down 75-degree column for number 2, 115 amps max current through the first wire. The second conductor or set of conductors is table 2, 75-degree number 1s, good to 130 amp. So the smaller ampacity is the 3 number 2 RW75s. So we have to size our overcurrent based off of that. And if you look at 14104, it tells us to use table 13. So we take 115 amps. That's not an available fuse or breaker, but we can look it up in our conductor range on the left side. And 115, it'll tell you that we can go as high as 125 amp overcurrent device. Okay, let's look at the next one. So in this one, we've got TW again. So if you go to table 19, you see that that's a 60-degree insulation. And we've got two 4-aughts. All right, copper. We have another copper here, RW75 and number 1. So we can use table 2 for copper. Look in the 60-degree column. Look up 4-aught, 195 amp max. If we come over here, there's two number 1s. So look up number 1s under the 75-degree column. That maximum ampacity is 130 amps. So 130 amps does not exceed the 195. This is the smaller number, so we're fine loading this up to 130, and we have to size our overcurrent based off the 130. So we take 130 amps, we go to table 13, and it tells us our maximum overcurrent is 150 amps. Okay, next, number 4. So in this one, we are using aluminum conductors. So we have to switch tables here. We have to go to table 4 for aluminum. And we've got 4 current carrying conductors. Okay, so if you recall back, as soon as the table 2 and 4 are only for 3 current carrying conductors or less. So if we got 4, if you refer to subrule 4 or rule 4004, it will refer you to table 5C, which are the correction factors for tables 2 and 4. So if we have 4 conductors, that means we can only load those conductors to 80% or 0.8 of their values in table 2 or 4. So we go to table 4, look up number 6 under the 75-degree column because of our termination temp. It's limited to that. And we see that it's good to 50 amps. We take 50 amps, we multiply it by 0.8 to derate it, and its maximum it has a maximum current carrying ability of 40 amps now. We're going to repeat the same thing. If you go to number 6 under the 75-degree column, again, it's the same thing. 50 times 80% is 40 amps. So both of them, we have to use a 75-degree column because of the termination temperature. So that's limiting us. And table 13, that overcurrent exists, so we're going to put a 40 amp overcurrent on there. Okay, next one here, number 5. We are going to have we have TW aluminum and this R90 aluminum. So the R90 once again is limited because of the 75-degree. The TW is limited because the insulation is only 60 degrees, so we can't overheat that insulation. We have 3 4-aughts. So if we go to table number 4, we're going to see that 4-aught in the 60-degree column is good to 150 amps. We go to 3-aught in the 75-degree column because that termination temperature, and we're going to see that it's only good to 155. So the larger of the two is the 150. If I take 150 and go to table 13, there is a 150 amp overcurrent device, so I'd have to select that. Number 6. Once again, we're dealing with aluminum, but we're also dealing with copper in this one. So I've got two 500. So I go to table 4 for the aluminum. Under the 75-degree column, I look up 500s, and they're good to 310 amps. Then I go over to the 75-degree column in the copper table. So table 2, 75-degree column. This is copper. It doesn't say aluminum. Table 2, 75-degree column for 500s gives me 380 amps. So the 310 is the smaller ampacity out of the two. So I will have to size my overcurrent based off the 310. 310 and go check out table 13, I can go as high as a 350 amp overcurrent on that. So 350 amp max. Number 7, we've got 6 number 4s, and they're copper, RW90, but we're still limited by the 75-degree temperature. And then I've got 6 number 3 coppers, but they're TW. TW only has a 60-degree Celsius rating, so they're going to be limited. I cannot let them get hotter than 60 degrees, so I have to use a 60-degree column. When you guys are looking at these tables, you can also think of these tables 2 and 4 as heat tables. So if I pull, let's 85 amps through a number 3, it's going to heat up to 60 degrees. All right, so you can use it in reverse order just to grasp that. And we don't want to overheat the insulation, and we don't want to exceed our termination temperature. Okay, so back to this, number 6. So we got number 3s. We got table 2, 60-degree column for number 3s gives us 85 amp. We've got 6 current carrying conductors. So we times that by 0.8. That value is available in table 5C. Gives us a maximum 68 amps. On the first half here, number 4s on table 2, 75-degree column are good to 85 amp. Times that by 0.8. It's also 68 amps. Table 13, look up, 68 doesn't fall on an overcurrent device. So go and look at your conductor ampacity range, and it says you can go up to a 70 amp overcurrent for this 68 amp maximum conductor ampacity. So the maximum overcurrent is 70 amps. Next. All right, number 8. Here we've got 8 TW aluminums and 8 RW90 aluminum, or 8 number 6 RW aluminum. So start with the first wire. Let's size that up. Once again, we have to use temperature correction factors. We're going to go to table 4 for aluminum. Because it's TW, I'm going to use a 60-degree column. Look up number 8s. You'll see they are good to 35 amps. Now, correction factors I have to apply to that because I've got 8 conductors. I have to derate it to 70%. 35 times 0.7 gets me 24.5 amps. And for the number 6 aluminums, 8 of them, I use a 75-degree column because of our termination. I'm going to go number 6, table 4, 75-degree column, 50 amps you'll find, and derate it to 75%. We're only good to 35 amps. So the smaller wire is the number 8 TWs. It can only withstand 24.5 amps max. So we size our maximum overcurrent, go to table 13, and we can go up to a 25 amp overcurrent on that one from table 13. One more. Okay, the last one here. We've got 2 number 12s, RW90, copper. So go to the 75-degree column. They're good to 25 amp. So that would, but this is a general branch circuit. So we are limited already to 20 amp max because of 14104 subrule 2. And what's attached to it is this number 16 GTF. It's equipment wire. If you read through 14-104 1B, you'll see that equipment wire number 16 gauge is considered protected by a 15 amp overcurrent device. So either way, our maximum, or sorry, according to the GTF, the equipment wire, our maximum overcurrent is going to be 15 amps protecting this. And that should be all of it. So hopefully that helped you out if you had any difficulties with this question in your ILM. Thanks.